to L. So if now we are having here A of I is less than B, so now we are checking that with T3 is less than B, go to L. Yes, it's going to be done like this. So this is of how we are executing each and every sentences, whatever we are writing in our code into a three address form. This is one example. So now the same thing, how we are going to be use that with the number. So because since whatever we are telling, that is going to be stored inside the compiler. We are discussing only about how the things are going to be shared inside the compiler, stored inside the compiler. So now the thing is, so each and every line is going to be written in one particular address. So for an example, we can take it here. So this address is going to be 100 is going to be written for this particular. This is going to be one sample only. It is not necessary that this instruction is going to be stored in 100. It is of any value. So T1 is equal to I1 plus 1. This is going to be stored in the position of 100. So I is equal to T1. This is going to be stored in 101. So it's going to be like that. It's going to be stored in an set of instructions, set of memory space. So here also we are going to save the same thing. So now a thing is go to L. Here we are writing and go to L. Instead now we have to write it go to 100 because we know the position of that particular statement. So we have to write it as a go to 100. So automatically it go to 100. It once again it goes off this loop. So once again it has to do all the set of this one, all the set of these 4 lines, and then once again just check that of this T3 is less than or be equal to V, less than V. If it is so, once again the loop starts and it has to be executed. So that's how that the 3 address code instructions are generated here. So we are having various types of this 3 address codes. One is going to be a quadruples, another one is having a triples, another one is going to be indirect triples. So what is a quadruples? Whatever we are seeing it now, that means we are seeing it as an argument 1 operator, argument 1 and argument 2. Now we are having another one as a result that we are going to store each and every state. Every step of that we are going to store that in that particular result value. The next one is going to be triples. Some of the times that whatever we are storing as an intermediate result, it is not necessary for us to store there. So to use of that memory, to avoid the memory wastage, what we are using is we are going to use this triples. In this triples, there is no need of the temporary memories we are using. Instead, we are using only the references of those instructions. So the next one is going to be an indirect triples. In this, we are having an in addition to the triples, we are using that pointers also here. That for each and every triple statement, we are using a pointer statement. So we can have one example for this to know about the detailed of whatever we are discussing about triples, quadruples, and indirect triples. So first we have to take an example as b into minus c plus b into minus c. So you have to write in 3 address code for this. So what is going to be in 3 address code for this? So check it out. This minus c is an one particular expression to be done. So what we have to use it of? So this is going to be a set of address formation we are having. So here we can use this second one, x is equal to OPY. So here we are going to write it as an T1 is equal to minus C. So the first statement is get executed minus C. Now we are going to have an T2 is equal to, now we have to finish off this one, B into T1. Yes, we have finished off this one, B into T1. So once again, we are having a T3 that is the same minus C, T4 is equal to B into T3. Then we have to add this 2. So T5 equal to T2 plus T4. At last, we have to give that to some variable because we need an answer to be get stored, because if it's an intermediate value, we are not able to retrieve that as an output. So we are storing that in one particular place, A equal to T5. So now we have to know how the 3 address codes are to be generated for the same 3 address code as a quadruples, triples, and indirect triples. First, we can start with the quadruples. So I already told you that quadruples has OP, argument 1, argument 2, and result. So argument 1, take the first statement as T1 is equal to minus T. So T1 is equal to minus C means the result is going to be stored in a T1. So what is an operator is going to be a minus. There is no 2 operator, only 1 operator is there. So 1 argument is there. So that argument is going to be C as an argument 1. Now the next one is equal to T2 equal to B into T1. So the same thing, what is going to be the output result value here? T2. So I am going to write it as T2 here. What is going to be the operator? Star. So star is going to be an operator here. What are all the 2 different things here? B into T1. So now the thing is B T1. I wrote it here. So like that, we have to write each and every statement. Each and every statement we are supposed to write. So A equal to T5 means A, which is equal to T5. So like that, the statement has to be written in the quadruples. So here we are showing each and every intermediate results are stored here. So if I want to avoid those intermediate results, because it is unnecessary wastage of giving an memory for that, then we need to go with the triples. So in the triples, we don't have any intermediate results value to be stored. Instead, we are having a particular position of that. So whenever I want to use this first statement answer, I need to do only this position. So here we see it here, minus c, that is going to be stored in 0. So if I want to get a value from it, I have to just use that position value here. That's all with the triples. So what does an indirect triples means? The same thing. The same whatever the triples we are using, this triples has to be stored in an another particular pointer. That means another place where we are having a storage and we can retrieve it easily. It is not possible for us to lose the particular values. So these are all the different types of pre-address code data structure. So almost once again, I'm telling whatever we are generating in syntax tree, that syntax tree has to be written in a form of a tree address code. So for any statement, we can write as a tree address code. After the tree address code, we can express that in any one of the data structure as in triples, quadruples, or indirect triples. Depends upon our usages. So now the next thing is how we are addressing the array elements. So the array elements we are going to be addressed as a two sets. One is going to be a row major, another one is going to be a column major. So row major means I have to concentrate first the row set and then I have to go with the column. So example, we are seeing that one, see it here. So I have to finish the first row and then I have to go with the second row. If I have to go with the column major means first I have to finish with the first column, then I have to go with the second column, then I have to go with the third column. So in general, default, it is going to be a row major. If we need to do that in the column major, we have to express that as a column major. So any two-dimensional array, we can represent in a form of two sets. One is going to be a row major, or we can go and call it as a column major. So now the thing is, we have to know how we can know. I already finished off with how the array elements are used. Now the thing is how the two-dimensional array elements are represented here. So the two-dimensional array can be represented as a row major or a column major value. So now the next one is going to be taken one example of another one thing. So if x is less than 100 or x is greater than 200 and x is greater than y, x is equal to 0. So this is going to be a one condition and this set is going to be another condition. So what we are writing is if x is less than 100, then go to L2. So L2, where L2 is going to be this, x is equal to 0. If false, if it is a false, then x is greater than 200, go to L1. That means L1 means we have to come out of this particular loop. If false, x not equal, because it's an AND statement. AND statement means if false, it's because both are supposed to be a true. If both are not true, then we need to come out of it. So first, if it's one is false, then it's a total false. So if it's false, then we have to come out of it. If it falls also, we have to come out of it. So for each and every statement, we need to write like this. So we know how we are supposed to write this one in the three address code. So any statement, whatever we are writing, that writing statement should be, we can write it in a form of a three address code. So another one thing here, so same thing, if x is less than 100, go to L2. L2 is nothing but x is equal to 0, or otherwise we can go to an L3 where it's check whether it's x is greater than or equal to 200. If it's so, we have to go to with the L4. So L4, they are checking whether x is not equal to y. Why? Because of if it is not true, then we can come out of it. There is no need of check this x not equal to y. So if it is true only, I need to check whether it is x not equal to y or not. So if everything is true, then I have to go to with an L2, or otherwise I have to go with any one of the choice with an L1. L1 is nothing but we have to totally come out of that loop. We don't want to execute anything inside of the loop. So with that, the thing is we can give off one major thing is how we can write any syntax tree format into a three address code in this video. Thank you.